Hello and welcome back from your Thanksgiving break. I hope everybody had a great break and you're well rested and ready to finish out the semester strong. I know we're not quite in December. This is the week of November 28th, but on Thursday is December 1st. So that is why I have the Hello December picture there. It is almost upon us. And to remind you guys that we are almost in December, which is the last day of our semester, is also in December. So it is right around the corner. We're about 3 weeks out. So just wanted to remind you of that. At this time, I want you to make sure you've got your math notebook out and you're ready to take good notes in your math notebook that will help you when you go to do this week's assignments. As always, I want to start with a warm-up that is going to help us review what we've been doing in our units about polynomials. So again, we are working in that polynomials unit in Edgenuity, and we do have a test coming up this week. So I did want to review factoring, which we did before Thanksgiving break. So in your math notebook, it is a great time to try these 3 problems that use factoring to see where you're at with factoring and helping you prepare for the unit test this week. So go ahead and grab your math notebook, open it up, and try to factor these 3 problems in your math notebook. Oh, hold on a second. I did want to change this to a negative. That should be a negative 12 in that second problem. It should be x squared plus x minus 12. So let's change that. Okay, go ahead and click pause. Try these in your math notebook, and when you're ready to check your work with mine, go ahead and click play. Alrighty, so looking at this first problem, there's no term in front of the x squared. There's no coefficient, I should say. There's no coefficient in front of the x squared. So when you have just an x squared with no number in front of it, we can use our foolproof plan where we look for the factors of our constant term, 8. So we look for factors of 8 that add up to give us that middle term, 6 there. So we look, and that will always help us factor. So what we want to do when we factor is we want to always put our x and our x here, and now we need to figure out what number goes here and what number goes here. And we can do that by using these steps. So we're going to look for factors of 8 that add up to equal 6. So what are some factors of 8? So 8 and 1. But do 8 plus 1, does that give us 6? No, so I know that wouldn't work. What about 2 and 4? So 2 times 4 gives us 8, and then 2 plus 4 gives us 6. So that's going to work. So both those numbers are positive. It's a positive 2 and a positive 4. So that means our 2 factors are going to be x plus 2 and x plus 4. And then it's factored out. Remember, you can always check your work by distributing, going through and distributing to check our work. So we could take x times x would give us that x squared. X times that 4 gives us that plus 4x. And then we have to take the x times the 2, that gives us plus 2x. And then x times 4, which is 8. And when we combine our like terms, that gives us 6x, which is what we originally started with, so we know we factored correctly. So the factors are just x plus 2 and x plus 4. That is factored out. So I'm just trying to get rid of those arrows so it's not confusing that this was our final answer. All right, so looking at number 2, we're going to do the same thing. We're going to find factors now of our constant term, which is a negative 12. So remember that negative sign is very important. It belongs to that 12. So factors of negative 12 that add up to our coefficient that's being multiplied by the x. And in this case, it's a 1. We've got 1x. We just don't need to put the 1 in front. So we're trying to find factors of negative 12 that add up to positive 1. So I know that since it's a negative 12, we're trying to find factors for. One of our numbers would have to be positive and one would have to be negative. So I know 4 and 3, when I subtract them, I get 1. So I know one of them's got to be negative 4 times negative 3 gives us 12. 4 minus 3 gives us positive 1. So our factors would be x plus 4 and x minus 3. And that's factored out. All right, so looking at our last one, we've got 2x squared plus 9x plus 4. So now we've got a 2 in front of our x. So the steps we've been following so far are not going to work because we've got a 2 in front of our x squared. So what we need to do now is I'm just going to use trial and error. So I know to start this out, I'm going to have a 2x. And then I'm going to have an x since I've got 2x squared. And then I've got to try and see what needs to go in our parentheses. So I know that eventually I have to get 9 as our middle term and then 4. So I'm going to try and do, how about factors of 4, so 1 and 4. Let's try that out. So what I'm going to do now is start distributing. So I'm going to do 2 times x, and that would give me 2x squared so that I can see if I need positives or negatives. And then 2 times 4 would give me 8x. And then 1 times x would give me 1x. And 1 times 4 would give me 4. Now I know I need to get a total of 9x. So actually this is looking really good, my trial and error. I would have to add these together. If I add 8x plus x, I get 9x. So I know that needs to be an addition sign, and that would give us a 9x. And then I know it's got to be plus 4, and there's got to be a plus signs here. So everything would have to be pluses that I put in. So the final answer is going to be factored would be 2x plus 1, and then x plus 4. And that was a really good trial and error. So those are our 4 answers for factoring. If you need more time on this slide, go ahead and click pause. Otherwise, I'm going to move on to the next slide. So some reminders. Remember, you should be taking notes as you watch your weekly recorded sessions, and this is to help you. It's going to help you when you go to do your assignments in Edgenuity. Taking notes, again, I say this over and over again, research shows that you get more out of lessons when you're taking notes rather than just being a passive observer. Make sure you're checking your grades frequently just to see how you're doing and what you need to work on to get your grades up, what assignments you're missing. And then just a heads up that there was a lot of work submitted over break, so I just ask that you please be patient with me grading that late work. I'm also trying to grade current work, so just be patient if you turned in late work. I promise you I will get to it. This week, so just some reminders for this week. The last day of the semester is December 21st. Guess what, guys? That's only like 3 weeks away. Can you believe that? So keep that in mind that we are so close to the end of the semester now, and keep thinking about your goal. How do you want to end the semester, and are you on track to achieving that goal? This week we're going to wrap up the unit on polynomials and Edgenuity, and we're going to wrap it up after learning one more thing in that unit, which is how to factor difference of squares. And then this week you're going to review the polynomial unit and take the unit test. And then we're going to start a new unit on quadratics, and we're going to use what we learned about polynomials to help us solve quadratic functions. So it might seem like there's a lot this week, but we're starting this week on a Monday since we had Thanksgiving break, where we usually start our weeks on a Tuesday. So we've kind of got one more day worked into this week's assignments. We've got another day. All right, so let's jump right in with the last thing we're learning about in Edgenuity in the polynomials unit. And so again, this is in the polynomials unit in Edgenuity. And the last thing you're going to do is learn how to factor a difference of squares. So what do I mean when I say a difference of squares? So here's an example of a difference of squared. X squared minus 9. So a couple things to notice here. First, notice that each term are perfect squares. So x squared, that's a perfect square because it's squared. The square root of x squared would just be x, because x times x gives us x squared. A perfect square, is when you can take a number and multiply it by itself to get that term. And then minus, because it's a difference of squares, so we've got a minus sign. And then 9. 9 is a perfect square because 3 times 3 gives us 9. It's got a perfect square. So another example of a difference of perfect squares could be like x minus 25, because 25 is a perfect square, x squared minus 36. Those are both perfect squares. So I think you get the idea there. They both have to be perfect squares, and there has to be a subtraction sign. Difference means subtraction. So we're looking for a difference, so we're going to have a subtraction sign between the two terms. So what do? How do we factor a difference of two squares? So if you've got two squares, anything like a squared, any number squared, minus b squared, there's a difference of squares. To factor them, you're going to follow this pattern, where a squared minus b squared, when we factor it, all we do is we take the square root of each number, and we add those two squares, and then we subtract those two squares, and that's all there is to it. So we find the square root of each term, we add them together, and then we subtract them. And that's how you factor a difference of two squares. So let's try that with our example here, where we had x squared minus 9. So what is the square root of x squared? It would be x. And what is the square root of 9? It is 3. So what we're going to do is we're going to add our two squares, our square roots of each of those, and then we subtract them. And that's the answer, x plus 3 and x minus 9. That's in factored form. Let's see what happens when let me move these kind of over a little farther out. So let's test that and make sure that works. So let's go ahead and distribute and see if that actually worked. So when we distribute, we always start with x and multiply it by x. We get x squared. X times negative 3 is negative 3x. And then we're going to do the same. X times 3 is plus 3x. Oops, see, those middle terms are going to cancel out. 3 times negative 3 is negative 9. So our middle terms, negative 3 plus 3, those cancel out, and we're left with just x squared minus 9, which is what we started with. So x plus 3 and x minus 3, that's factored out. That is factored out. That's how we find the difference of two squares. Not bad, right? Let's try some more examples. I'm going to go on to the next slide, so if you need more time to copy down in your notes, go ahead and click pause. All right, two more examples. X squared minus 25. So remember, if we've got x squared minus b squared, to factor that, we find the square roots, and we just take a plus b and a minus b. So what is the square root of x squared? That would give us x. What is the square root of 25? It is 5. So now, to factor the difference of these two squares, we're just going to take x plus 5 and x minus 5. And we're done. That's it. So go look at number 2 and see if you can do this in your math notebook on your own first. So we've got our two perfect squares, x squared and 16. So find the square root of each of those and add them and then subtract them. So go ahead and try this in your math notebook. Go ahead and click pause, and when you're ready to check your work with mine, go ahead and click play. So first, what is the square root of x squared? That would equal x. X times x gives us x squared. And the square root of 16 is 4. So to factor, we're going to have x plus 4 and x minus 4. And we're done. We factored it. And that's what you're going to be learning about at Edgenuity this week. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. One more for us to try. So now we've got 9. Ignore that little blue dot. I don't know why that's there. Let's see if I can cover that. It's kind of weird. It should be not there. So just ignore that. It should just be, I'll just rewrite it, 9x to the 4th minus 16x squared. So now we've got coefficients in front of our x terms. A little different, but we're still going to attack the problem the same way. So what we want to do is first find the square roots of each of our terms. So what is the square root of 9x to the 4th? So what times itself will give us 9? 3. The square root of 9 is 3. What times itself will give us that x to the 4th? So remember, anytime we multiply two variables, the same variables, we add the exponent. So if we want to get 4 as our product, then we would have 2 plus 2. So the square root of x to the 4th is going to be x squared. And then let's do the same thing with, how do we find the square root of 16x squared? Well, the square root of 16 is 4, and the square root of x squared, we've been doing that, is just plain old x. So now we're going to follow the same pattern where we take that first term, the 3x squared, and we add it to 4x. And then we're going to take that first term, 3x squared, and we're going to subtract 4x. And we're done. Same steps. We just had a coefficients to work with this time, which is no big deal. We did it. I'm going to go on to this next slide, so if you need more time, go ahead and click pause. And then, as you get to the end of this week, after you finish up the polynomials unit, we're going to start the quadratic equations unit. And so a brand new unit in Edgenuity, and the first thing we're going to learn about is the zero product property. And the zero product property just states that anytime you have two numbers, and when you multiply them times each other and they equal 0, so anytime you have two numbers and multiply them times 0, then what we're saying is that one of those numbers would have to be 0, right? Think about that. Any number times 0 gives us 0, correct? So if you are stating that two numbers or two terms, if we multiply any two terms together and they equal 0, such as a times b, then we know that either a has to be 0 or b has to be 0, because anything times 0 gives us 0. So for example, if I had like 5 times x equals 0, what would x have to be? It would have to be 0. X would have to be 0 because 5 times 0 would give us 0. So we're going to take that a step further now and look at when we've got polynomials in a factored form. So here we've got x minus 5 and x minus 3. And look what it's set equal to, 0. So we want to find out what our values of x can be to make this equation equal to 0. So if we take x minus 5 times x minus 3 and we set it equal to 0, what are our possible values of x that would make the equation equal to 0? So what we're going to do is the first step is we're going to set, maybe I should write over here, steps to solve. The first step is we're going to set each factor equal to 0. And then we're going to, second step is we're going to solve for x. That's really all there is to it. So what does that mean? So when I say set each factor equal to 0, well, we have two factors. We've got x minus 5 as a factor, and we've got x minus 3 as a factor. Those are our two factors, and we're going to set each of those equal to 0. Each of those equal to 0. We're going to treat them as two different equations, and then we'll solve for them one at a time. So let's do the first one. X minus 5 equals 0. To solve for x, I'm going to do the opposite of what's being done to it. Since x is being subtracted, I'm going to add 5 to both sides, and x would equal 5. So one of my solutions would be x equals 5. Or we've got this equation over here, x minus 3 equals 0. So to solve for x, I'm going to add 3 to both sides. And x would have to equal 3. So in this case, my answer would be x equals 5 or x equals 3. And the reason is if we plugged in, if we said x was equal to 5, look what happens. If we plug, I'm going to move our steps over here. If we plug in x equals 5, we would have 5 minus 5 times 5 minus 3, and it needs to be equal to 0, right? Well, 5 minus 5 is 0, and then 5 minus 3 is 2. Anything times 0, 2 times 0, guess what it equals? 0, so it works. Or on the other side, we could have had our x equals 3 is our other possibility. 3 minus 5, we'll plug in 3 for x. 3 minus 3 equals 0. 3 minus 5 is negative 2. 3 minus 3 is 0. What is negative 2 times 0? It is 0, so that worked. So our two solutions could either be that x equals 5 or x equals 3. And again, the steps that we use is we set each factor equal to 0 and then we solve for x. So let's try that second problem. Let's try this second problem. We've got 4 times x plus 3 times x minus 6 has to be equal to 0. So what are our two factors? So we just want to focus on those two factors. That's our first step. So what are our two factors? Our two factors are x plus 3 and the other one is x minus 6. We can ignore that 4 out front. Just ignore it. We just want to, for now, focus on our factors. So we're going to take each of our factors and set it equal to 0. Each of our factors and set it equal to 0. And then we solve for x in each equation. So here I'm going to subtract 3 from both sides and I would get x equals negative 3 as one of my answers. Or, in this case, I'll add 6 to both sides and I get x equals positive 6. So those would be my two possible answers. Done. I'm going to go on to the next slide. So if you need more time, go ahead and click pause to take down good notes. And let me put up your, we are done with the recording, so let me put up the key phrase assignment question. So one of the things we learned about today was how to factor a difference of two perfect squares, which I have written up there. And that's what I want you to do. I want you to factor x squared minus 25. And if you need any help with anything that you're doing this week, remember I'm always here to help and answer questions. So send me a quick message and I will get back to you and help you out. Have a great rest of your week.